So just listen, please. Just listen for now. I'll take questions in a minute. So it's the same problem as we left off with yesterday. Okay, we start with our formula. Area times volume equals area times volume, continuity equation. We then say that our area was a circle, so it's pi r squared and pi r squared. Inlet is 1, outlet is 2. We're told that the inlet radius is 5. We're also told, let's try that again. We're told that the inlet radius is 5 here. We're told that the inlet velocity is 20. We're told that the outlet velocity is half of the inlet. Half of 20 is just 10. And we're asked to find the radius of the outlet. We go ahead and plug these numbers in, cancel our pi's on both sides. We can then solve for R2 analytically. We move the V2 over here by dividing by V2. We're left with R2 squared. We take the square root of both sides, which yields this equation over here. From this equation, we can see that we can simply plug in to get R2. R1 is 5, so we do 5 squared times the 20, which is the inlet velocity, divided by the 10. 20 times 10 is going to be 500. 500 over 10 is simply 50. And what we notice is that 50 factors into 5 radical 2, really, and we can see that that's approximately 7. Well, you might ask, where did the 5 radical 2 come from? The 5 is the radius from the original part, and we're multiplying by a factor of radical 2. Where does that all come about from? We go back to our analytical solution. We replace V2 with 1/2 V1, because that's what V2 is. It's half the velocity. So we replace that with 1/2 V1. The V1s both drop off on each. We're left with R1 squared over 1/2. Dividing by 1/2 is the same as multiplying by 2. If you have R1 squared and it's a square root, the square and the square root cancel, the R1 comes outside. We can see that the second radius is not double the first radius, but the factor of radical 2 multiplied. Okay? The key point here is this. We made that conclusion yesterday that if we have the velocity, we double the area. So normally you would say the area 1 is if we have the velocity, area 2 would be equal to double area 1. That's what we would have really. Because if we have the velocity, we double the area. But here, we're looking for the radius. And the radius is really radius squared. Isn't that how you get the area? Mm-hmm. So really, instead of a 2, we got to go backwards and think about it as the square root. Because to get the radius, how would you solve for the radius? You would take the square root, right, from the area? No. So if you have the area and you want to put it in terms of the radius, you got to take the square root of both. Because the square root of the area is really the radius, with a pi in there, obviously. With the pi cancels on both sides. So we have to really radical off it. Okay? Julian?
My question is, so is it going to be always going to be like that? Like, say, for instance, say if it was, so
this is, you can always, Julian, you can always remember that. That's another thing you want to write down if you'd like to, sure.
So
because what have we done here? We've solved for analytic solution. What does this happen though? Julian, what if the velocity, instead of being half, was cut in 3? What would be the difference?
Then we had the radical group.
Radical,
3.
It's 3, triple, yes.
Okay.
So again, if the velocity was cut in 4, so if the velocity was 40, and then the velocity was 10, it's cut in 4. So this would just be the square root of 4, which would turn out to be 2 actually. If it was 5, if it was cut in fifths, so say the inlet velocity was 50, and the outlet velocity was 10, this would be just the square root of 5 here. So what is this called? What is this 2 called really? What would you call it? Think back to geometry. Think about when we talked about, think about when we had shapes that got expanded. What do we call that?
Expanding shape.
Like a triangle, like this, 3 by 3 by 3, and then a triangle 6 by 6 by 6. Aren't they similar? What was the factor called?
It was like 2 years ago. Are they similar triangles? Like, no. Is it ratio?
Yeah, but what was the factor called?
Rational, proportional?
No.
They are proportional. There is a ratio. You're right. I'm asking what the factor was called.
I don't know who lied to you.
Called it the dilation factor.
Oh.
Okay, remember it was like D and then D squared and D cubed for volume? That's really what this is. Doesn't matter right now, okay? Again though, this number here is simply the ratio of the first velocity to the second velocity. That's what that is really. Remember the first velocity was 20, the second velocity was 10. 20 over 10 is where that 2 comes from. So Edgar, you're right. It is the ratio, but I want you guys to think about dilation. That's where that comes from. Okay, it's used here. Let's do another problem like this. Let's do one more, and then we'll get on to the next topic. We're almost done with fluids, by the way, guys. Today's really the last day of lecture. I want to do some more problems on Thursday and talk about like maybe some other stuff on Friday. But then next week, we're actually going to have our next test already on this.
Already?
I know, it's a quick topic. There's not a lot of fluids. And this is good because you know what? The next few topics are, I think, the most interesting of the year. We're doing heat. We're doing heat next. Then we're doing vibrations after that. And those are two really cool topics. I think you guys will like them. They're a lot. They're very applicable. Okay, they're used a lot. Tomato, tomato.
They call it Green Lantern. Yeah, that was a disappointment.
What?
Superman Returns and Green Lantern was just disappointment.
I'm laughing.
Captain America's batting one.
Actually, the Hulk was not that bad compared to the first one they were coming out with. That movie sucked.
That's right, please. Come on, you can talk all right. Let's go. If the cross section
So don't tell me what to do.
of a pipe is a triangle, if the cross section is a triangle, okay, this happens, believe it or not, depending on the space you have. It really does. I know it's weird, but imagine like ductwork that runs the air conditioning through the system.
Ductwork?
Ductwork
Oh.
running through the system. It could be a triangular shape. It's very simple to do that. Or you know what it could be? It could be rectangular with a split because the airflow is going to split into two rooms. So you could have a rectangular HVAC system that has a panel that cuts it across, which really gives you two triangular cross sections. So this is very applicable here.
Does that reduce the amount of air which is being...
Absolutely. Change your pressure head, it changes all that. Yep. But it's used because you have to split the section, right? How do you get air in all the rooms? There's some big spot that then branches off into all the others. So here, if the cross section of a pipe is a triangle, and its base and height, or let's say its base is increased by a factor of 2. If its base is increased by a factor of 2, and height is increased by a factor of 3, this is at the outlet, by what factor will the velocity decrease? Okay, by what factor will it decrease? Remember, think about the hose example. When you have a garden hose in your backyard, you put your thumb over it, it comes out faster, right?
No.
Because you're decreasing that area. Now here, we are increasing the base and increasing the height. So we're increasing the area, right? Thus, the velocity has to decrease. So that's correct at the end to just check. But the question is this, we got no numbers here, right? I don't know velocity, I don't know what the area is, all I know are all these factors. So let's draw ourselves a picture, just to get a visual. So I've got my first section, so my inlet, and then my base was increased by a factor of 2, and the height was increased by a factor of 3. So if I call this x, and I call this y, this is now 2x, and this is now 3y. Is that clear so far? Think about what this means. We said that the inlet was increased by a factor of 2 on the base to the outlet, and by a factor of 3 in the height. All right? Now, at this point in time, we got to start thinking, by the way, this would not be as applicable. Changing cross-section of a triangle would be very complex. Here we're talking about what's called an annular cross-section. We'd have to slowly get bigger, which is kind of weird. This would have to be like, you would have this one shaft coming through, air is flowing through, then there's an automatic jump, and then the rest of the shaft. It wouldn't be like a slow change or a gradual change. Okay, very difficult to manufacture something like this, but it is possible. What I'm trying to get from here, from this problem, is the idea of factors, though. So, with that said, let's start with our formula, please. And I'm going to write the v a little bit smaller, sorry, because we got to remember that it is velocity. Now, before I actually do this problem, think about what's going on. What are we trying to find here? Which velocity? At the outlet, or the difference between them. So solve for V2. That's what we're doing here. Again, you're trying to find the factor by which it goes down. By what factor does it actually decrease? So here, solve for V2. Okay, start by solving for V2. Now, tell me something about the areas. Who can give me some information that I can use here about the areas?
Oh, the formula for trying to base times height. So you use that.
Base times height,
Half.
half of that. Very good, thank you. So the area of each is going to be 1/2 base 1 height 1 V1 over 1/2 base 2 height 2. Again, what did I do? I did nothing but plug in my area of a formula, area of a triangle. This is basic geometry. If you don't know this by memory, please memorize it. You got to know this kind of stuff by now. Okay? Now, at this point, we know what these values are. Base 1, what did we call base 1 back in our diagram? And what do we call height 1? Again, this was base 1, this was height 1. And then over here, that's base 2 and that's height 2. Go ahead and plug them in.
So don't the one have to cross out? Yeah. Alright.
Okay, and you notice that right away. Good, the 1/2s. You got a 1/2 up top and a 1/2 down below, they cancel. Base 1 was x, height 1 was y, v1. Base 2 was 2x, height 2 was 3y.
The Y's come off?
What do you notice about the y's? What else? And the x's. You said once. X cancels and y cancels.
Oh, I meant.
So what are you left with really?
Over 6.
So by what factor did it decrease, guys?
6.
6.
Time out, I was going, but you know, I was going to say that, like, don't you just multiply 2 and 3 and say 6?
Mhm.
So I was right the first time.
You could write 6xy, and then you have xy here. See, this is really 6xy when you multiply those. The xy's cancel with those xy's. You're still left with v1 over 6. So this tells me that if you had some initial velocity, you take 1/6 of that, and that's what you get as the exit velocity. Because it went down. It must have decreased.
But that's only for like sudden change. Like it's not gradual.
No, it could be gradual or sudden, either one. But what we're looking at is beginning and end. We're not looking at what's going on in between.
Yeah, I thought
In
that-
between, it would be different, yeah.
Yeah.
You'd have to look at the flow being a function of time. So the velocity would be, for example, 10, 8, 7, 6, 5, 4, 3, 2, 1, until it gets to the small spot, and then it'll be 1 from there.
So it's everyone if it's like every section of the
Change
pipe
by a certain
change,
amount, it
you have
changes
to-
the,
Yeah.
and that's where you use calculus value. You have to do that there, okay?
Later rates.
It's like a related rate, actually, yeah. All right, so again, it is 1/6 of the initial velocity, 1/6. So by what factor did it decrease? 6. Again, the question asked, this is very tricky. A lot of people answer was 1/6. It said, by what factor did it decrease? The factor is 6. Okay, the factor is 6 here. It's a little bit confusing.
What's being divided? But the base.
What is it being divided by?
6.
6.
So yeah, I got you.
If I said how much of V1 is V2, you would say 1/6 of it, right?
Yeah.
It's 1/6 of it. By what factor did it decrease? A factor of 6. Kind of weird. If the question said, by what factor did it change, then it's 1/6, which is really weird, because that's different. Again, if it said, by what factor did it change, that's 1/6. But by what factor did it decrease, because they're already indicating the decrease, you just say 6 there. Very different things. So V2 decreased by a factor of 6. That's one way of writing it. Second way of writing it, V2 is 1/6 of V1. It's another way of writing it. Or you could say V2 changed by a factor
Students in Mr. Brower's
of
oral period
1/6.
meeting syndrome.
Any of those answers are correct here. And I want you to make sure you understand the difference.
Mr. Brower, fourth period will be.
Decrease.
207.
Decrease means that we know it's going down already, but what factor, that's the number it's getting cut by. It is 1/6 of V1 because it says V2 equals 1/6 of V1. Because I could also write this, remember I could write this as 1/6 V1 equal V2. That's the last two parts there. These last two parts you see that I've written, those statements come from the green expression over there on the left. Okay? Which are different things, I understand that. But I want you all to understand that there are different expressions. And to me, I would never do this to you guys, but just so you know, the common trick that a lot of teachers do, they make the choice 6 and 1/6. And then so many people get it wrong because of that. And that's not what I'm trying to test here. I'm trying to test the fact that you understand that it simply gets smaller. Okay, so I'll ask you one way or the other. I'm not going to make the choice 6 and 1/6, and then you have to figure out all the wording behind it. But I do want you to understand that you can represent things with more than one expression. Okay, you don't have to just make one statement. All three of those statements there are all equivalent. Okay, but you're not going to see 1/6 and 6 as choices, because that just is made to confuse people. And that's not what I'm testing you on. Okay? Make sense? AP exam, you'll have 1/6 and 6. Okay? For calculus, guys, you got to know the difference here for sure with these, because you'll see that, and they'll put 6 and 1/6 on purpose on the AP.
So what part two?
It depends on the question. For our question, it said, by what factor is it decreasing? 6. Okay? If the question had said, how much of V2 is V1, or vice versa here, that's where the 1/6 would
So
come.
part two,
Okay?
part two?
Yeah, they might ask that for velocity and flow rate and stuff. Okay?
They wouldn't put that for a multiple choice, maybe?
No, I'm sorry, that would be a multiple choice, because they would have the 6 and 1/6.
Yeah.
That's why I wouldn't start that process.
I've been going through your video.
All right. I wanted to talk about one other thing, but I want to make sure before I do it that it's working.
It's just a... Sure. I know, I was trying to
Bernoulli's, B-E-R-N-O-U. Okay, B-E-R-N-O-U.
I was gonna get the joke without her.
Isn't that a pot?
Yeah, exactly, that's right.
It's here.
Sounds like a restaurant.
Funny guy.
Sounds like a sandwich shop.
Sounds like a deli in the city, is that what you said?
Yeah. Sounds Thai, that's what.
Bertucci's is a restaurant, it's an Italian restaurant.
Yeah.
What do we say the bitch pasta?
You know what's really, you guys want to get real good Italian food around here? Most people don't know, some of you, who lives in Silver Spring around here? So you might know this place. What? No. Ever been to a Lazo's?
Oh!
It's off the hook. I mean, the best food I've had. Hands down, any Italian restaurant ever, the best food is at the Lazo's. It's in Silver Spring. They own me. Okay. You know where downtown is? Walk south on Georgia a little bit, just like up the block. It's right there on the side. You know where? Walk away from downtown toward the parking garage. You know where the parking garage is, the Winnie parking garage? Go in that direction on Georgia, and if you're walking on your left side, you see where there's like an extra part of the road where people park over there? It's like a little park where you can park. Palazzo's, it's like a black sign with an Italian flag. It is they have the best calamari I've ever had. And like, my grandma's been, so, but at a restaurant.
Do they make notes?
I don't know. I've never had dessert. I've had 3 dishes there, and they've all been the best ever. I've only been there 3 times. And they're really good.
Watch me get those 3 dishes.
I get the linguine with steak, and then the penne al vodka with shrimp. Those are the 2 that really. They're not really good. But the calamari is phenomenal. Where are we going?
I like fried calamari.
It's on Georgia Avenue.
I know where it's.
I've heard of it.
I've only seen the flag.
What used to be next door? No way.
I don't know. There's no studio place that they built, the big one.
I still think Bridget out to it, right?
That's where he's
I'm really good at it.
Where is it now?
Then there's a hair salon
Where is it now?
near Walgreens.
Okay. Veterans Center?
The old one?
But I was saying that, have you ever tried the grill?
Hey, there was China Grill?
The grill?
Yeah.
The Jamaican restaurant?
No.
It's like in that, on that.
It's good?
Yeah.
We got gyro or gyros there also.
Under the braid.
Alright, let's talk about Bernoulli. Huh? I'm so hungry right now too. Sorry. I'm sorry. I've been hungry all day though.
There's another one. There's another one. Chocolate candy.
So the Chinese food restaurants are American.
You gotta go, no, you go under that braid.
Oh, yeah.
Why are you doing that?
I like Korean.
I don't like Thai food. I don't like spicy.
And you know what the other good part is? It's not that expensive and you get really big portions there too. I mean, it's not like cheap or anything. You're gonna pay like $12, $13 for your entree, which is normal, but you get a big portion. I always bring some home, and the calamari you get a lot. I would get that as an appetizer.
Oh, is that the one that you were talking about?
Yes.
Yeah, I'm gonna go there like.
Spaghetti.
That's why I went
I mean, we gonna go to lunch, but.
Yeah, I'll do that at my house.
Maggiano's?
Yeah.
The family style one? Yep. It's pretty good, yeah.
Is there anything fancy?
There's another one like that by Villanova I've been to also. There's Maggiano's there and there's another one just like that. They're usually really good. Vinny T's it's called. Alright.
Oh, wow.
So, one thing I want to note here is this is a very big misconception. I'm going to put misconception alert.
My sister works here, and the joint's like right here. What's the street from my sister's job?
The place?
Yeah.
So, remember yesterday when I asked you guys a question and a few people said the opposite. I understand why. Remember I said like if you put your thumb over the hose, it's coming out faster, right? And I think Kenny said we're building up pressure. Oh, who was it then? Who said building up pressure? Either way. And that's what you know what, the first time I thought of it, is that what you think? Don't you think you're building up pressure by putting your thumb over the hose?
No.
It's the opposite actually. It's the exact opposite. The fluid's pressure decreases as the velocity increases. So when you put your thumb over the end there, the velocity is increasing, you're actually decreasing the pressure. And here's why. And this is very confusing to think about, and I'm going to show you a diagram. Imagine you had a fluid, any fluid, water, whatever it may be, flowing through a hose, and the hose gets narrower as you go along. Okay? Now, what you're going to say is that the velocity goes up because the area goes down. We know that. So this is V1, and this is V2, and we know, please listen, V2 is greater than V1 automatically. We know that. We already proved that. That's the continuity equation. The velocity goes up if the area goes down. That's standard. Now think, though, what causes this increase in velocity? Think back to kinematics. When you have a change in velocity, when do you only have a change in velocity? If you have what? Acceleration. To have acceleration, you need a force, don't you?
Yes.
To have a force, you need a net change in pressure. Okay, you need a net change in pressure. And what you're going to notice here, though, is that the pressure here is greater than the pressure here. Think about that logically. If this pressure is more than this pressure here, isn't it going to push it? Think about it this way. Don't think about putting your thumb over the end now. If this pressure is higher, doesn't pressure mean it's kind of like pushing it along? So P1 has got to be more than P2 so that it can push it along. So in this case, you end up getting P1 greater than P2, which is the opposite of what you would think. A lot of people think that the pressure is higher at the end because it's coming out faster. It's the opposite of that. And I'm giving you the logical example. There's a lot more you can do, and you can derive it with formulas, but you need differential equations and some calculus involved. So I'm just going through the general idea for today. Again, you have a lot of pressure here, and the pressure here is higher than this pressure, thus causing an increase in velocity. Okay, you need to have what's called a pressure gradient. Pressure gradient just means there's a change in pressure. So what you want to write down is Bernoulli's principle right here, and think about this image. Now, you might be saying or might be thinking, that's great, and we're going to use this in piping, but where does it really come into play? You know where this comes into play? Airplanes. Airplanes. Without Bernoulli's principle, without this being true, we would not be able to fly. That's how birds actually fly. So let's discuss this. Okay?
Wait,
So-
have you seen this video of someone who actually went from Honduras?
Well, yeah, that's big. Did I hear about that guy who touched the bottom of the ocean? 35,000.
Oh my gosh, he touched
And a special submarine. I read it.
five cool.
Can you put that link? I would love to see that. Send me that link.
It's,
Valpo, what was yours? Sorry, your daughter first. I ignored you first. I didn't hear what you said.
I mean, basically what happened was, there's this guy who...
Guys, one at a time, one at a time.
There's this guy who's been working on a project for about like 8 months on trying to actually literally just fly, like manually. Like no.
So is he building wings and stuff?
Yeah.
He literally built wings and he actually started flying.
But I think people saying it's fake. I saw it.
You were saying it's fake?
Yeah.
Yeah.
Because the dude.
Let me see it, yeah.
Wait, did you know that?
Send it to
Did
me.
you know that one that we saw about walking on water?
That was real. That was real.
They put it on Netflix and
Which
everything.
What'd they say?
They said it was wrong.
They said it was wrong?
Yeah.
Which one?
They said it was fake.
Absolutely not.
Because they were like.
What were they
at
saying?
the bottom, they probably use what you call it?
Well,
Wood.
how would it-
Wooden floor, and they stuck it there.
Well,
That's
if
why
that
they
happened, that's
did it.
different. But think about logic. How do chameleons? And
I know, I know.
how do they stay on water?
You guys remember that video about the guys walking on
He's
water?
talking. I know. He's talking about the one where they were running and they
They
got like
actually sent it to
water.
Mythbusters, and they said that I forgot. They got
Send me that one too, because I'd love to see
I
that.
do that thing. You saw him fail. too.
I thought it was real. It looked like they were falling to different locations.
Because they
How
were
did
like,
they do
maybe
that?
we're not fast enough, so I actually got a track person, and they actually, like, he had to practice for, like, months. They had him practice for a while.
But here's my, I agree with you and I understand what you're saying. But the guys kept falling at different locations, didn't they? They never fell to the same spot. So if there was wood there, how could they have fallen at different spots? You know what I'm
Yeah,
saying?
I mean, I was arguing with
So
my
that's
dad.
what I was thinking about myself.
My dad had
They
like
kept
a
falling at
40-minute
different
argument
locations.
over it.
Unless they paused the video and moved the wood out further, that would be really
Wait, what
misleading.
video though?
Remember the video in the beginning of the year where the guys were running on the water and they had these like special shoes that were water resistant and they were trying to run as fast as possible and then they got, what did they do? Didn't they like, didn't they get pulled in at one point?
Yeah.
Didn't they hook themselves up to something and get pulled in? We watched the beginning. I'll put it on Facebook. We watched it. Alright. So what I want to talk about is a wing. A wing is called an airfoil. So let's write this down, please. You're going to use this term if you ever study it. Airfoil. An airfoil simply means a wing. It's a fancy word. Airfoil just means a wing. And generally speaking, here's what you see as a diagram for a wing. That's what a wing looks like. I know it doesn't seem like it at first, but think about the cross section of a wing. If I drew an airplane here, okay, and if I were to cut this like that, what you're going to see is that the wing actually comes to a tip here, and it looks like that. That's what the cross section looks like. Okay, again, the wing comes to a point at the end, and it's curved around the front. The curvature is so important, it's unbelievable. The curvature is what affects it. Have you ever been in an airplane and you look out the window and you see these little boxes here, and then they move up and down? What are those called? The flaps. The flaps, what they do is the flaps provide resistance or lift. And what we're going to talk about now is how lift occurs. But the flaps assist that. We're going to really talk about the wing first.
So this diagram is like a picture of the wing, but you cut it.
You know how I always draw a box for objects? Whenever you draw a wing in engineering, that's what you're going to see. Okay? You're taking the wing and you're slicing a piece of it and you're looking at that cross section. Okay? So, here's how the flow looks around the wing. What you see is this. You've got all these airflow waves coming in, all parallel to each other. Okay, the air flows in parallel lines. But something's got to happen, right? It can't flow through the wing. We agree with that? But nothing goes, air cannot flow through mass. Unless you have like a filter or a screen. But this is a solid. Air is not going to go through. So what we have is this. We've got this like bunched up region here. It looks like this. And down below, we've got this other region down here. Now, what you're going to notice is that the waves down here, they actually do not bunch up. And I'm referencing, if you want to look in your book, page 286. you want to write that down to look later. The diagram in the book is better. Well, you know what? I've got the book. What am I doing?
Really though? We're only on chapter 9?
The book is Physics 1 and 2. Physics 1 is mechanics, Physics 2 is electricity and magnetism. All physics books do Physics 1 and 2. So we'll get through more than half the book. We'll probably get into a good amount of... by the way, that was the diagram from yesterday that I used. All these diagrams, I pull a lot of them out of your book. Okay? Where's today's? That was the diagram of Bernoulli's principle we just used. Here's the airfoil diagram right here. Okay, can we zoom in a little bit? Can we zoom in? No,
It's
maybe.
not an iPad.
It works if I do it on my screen, which is weird. It does. Watch. Ready? Not lying to you.
Can you like your doctor?
It's funny though, because I have a product.
Oh my God, you should just go home. Be like, okay, is that for God?
All right. So here's the actual diagram. What you have here is a imbalance of pressure. You have an imbalance of pressure. And if you want to just read, it says, as air flows around the airplane wing, airfoil, they don't use the word here, it's not a technical book, the air above the wing moves faster than the air below. Now, if the air above is moving faster, there's a low pressure up here. Okay, and here, there's a high pressure. Because again, we just said a minute ago, as the velocity goes up, the pressure goes down. So there's low pressure. If you have more pressure below than above, what's going to happen? It's going to lift up. And that's where this force due to the lift comes about. That's how an airplane actually runs. Now, there's something called drag. Drag is air resistance. And if the force of lift is greater than the force of drag, you fly. That's pretty much what an airplane is. It's, believe it or not, I know it took a long time for the Wright brothers to come up with it, but once they came up with these developments, it's one of the most simple things ever. It really is very simple now that we know. And if you guys noticed, have you ever been on an airplane before?
Yes.
Okay? Some maybe, some no. If you ever do go on one, if you have already, think about when you're on the plane. The pilot takes off. Okay, the pilot takes off. After he takes off, he doesn't do anything. Literally. He just lands. He puts it on autopilot, okay? And then now, here's how it works. Imagine a wind comes in. So a wind comes in, and suddenly, like the left wing gets pushed up a little bit. What it does is it adjusts that flap. Remember that flap we're talking about on the side? Those flaps are adjustable. So if there's too much lift on one side, it will lift up the flap to create more drag to lower the plane back down.
I couldn't see that.
So that adjustable flap changes. And when you land, ever see when you land, those flaps turn almost perpendicular. Because when they're perpendicular, isn't that going to be the most resistance? The air is going to be slamming into the flap. If the flap is like this, the air kind of runs off, right? If the flap is like this, it really runs right by. But when the flap comes down like this, all the air slams into it, causing the plane to slow down. Okay, Jordan. His why do I know it?
His name is Michael Weston.
I read.
He didn't have a date on a Saturday.
When I study engineering, I'm not going to comment. When I studied engineering, a lot of the classes you learn application. So I took fluid mechanics, a whole course. You know, we just learned in a chapter. I took an entire course for a semester on this. Hardest class I ever took. It really was insane. And the second hardest. It was with this guy, Dr. Wu from Japan. Amazing teacher. Amazing teacher.
But you can't understand a word they be saying.
All the teachers at Villanova in English in the engineering department know perfect English. I never had an issue with that ever, and I'm not messing with you. I was lucky to have that because there were a lot of teachers from India. There were a lot of teachers from China. There were a good amount of teachers from Japan. I'm just telling you, that's what they were. Every one of them knew fluent English, and they knew better English than I did. Their writing was so much better than my writing, and that usually happens. A lot of people that are foreigners learn English the right way. We learn English as a kid in such a bad manner because we hear it. How was the first time? You don't learn by writing, right?
You
You
don't
learn
learn.
by hearing as a kid. And you hear all the imperfections. For example, when I say stuff like ain't, I'll say that once in a while, but that's not grammatically correct, right? You say isn't. Or for example, I don't know, what's something else?
What's up?
What's up? Okay, yeah. You wouldn't say that, right? I mean, it's not, you wouldn't, I'm sorry, you would say it, you wouldn't write it though. You would never write what's up in a paper. You wouldn't even write what's up in a paper, really. You know, you might, if you were talking about it, you might word it differently. So, Julian, back to your question. In my fluids class, we studied pipe flow, we studied airflow over airfoils, and then later on, when I learned about dynamics and system dynamics, what we learned about was really cool, was those, remember those if statements we kept talking about?
Yeah.
If this, then that. I'm going to show you in a minute a diagram you like from Big Bang Theory. And they use one of these diagrams. I know, we're about to... And what we learned in this class called System Dynamics was this. We learned that if there is some sort of a... Please listen, guys, come on. If there is some sort of a perturbation, and a perturbation just means a deviation from the normal. So if there's a wind that comes in and it causes the plane to lift, what causes the flap to automatically change the angle? Well, the engineers write codes and systems so that if the pitch of the plane or the yaw, these are two different terms, if the pitch or yaw change, the tilt, it automatically adjusts a certain degree level in an instantaneous quickly. So like it notices that the pitch is off, automatically the flap changes so that it balances back out. And that's called system dynamics. It's the same thing as your car. Go in your car, tell your parents sometime soon, or if you're driving and you're on a highway, and you're driving like 60 and there's no cars near you. Throw it on cruise control. Throw it on cruise control, please. Then what you're going to notice is it maintains 60. Well, it doesn't lock it. It doesn't lock the wheel. It doesn't lock the accelerator.
With the cars can go on auto.
So cars are on autopilot, yeah, but you have to do steering, but the speed stays.
If you like going along,
Yep. I drove cross country with a bunch of friends when I was a sophomore in college, and we used the auto or cruise control in cars, not autopilot. For cruise control, we were driving one strip that was a straight road with literally one lane, no speed limit at all, because it's in the middle of nowhere. They don't have speed limits. So we just did cruise control at a certain speed the whole time.
Cruise control 100.
You have to get your foot on the
On those roads, the speed limit is unlisted. It's not illegal. We're not saying it's safe. You should have. So
I'm just saying that if I know that if you hit something, we're not going to survive it.
yeah, it couldn't be that good. That's true. Or set.
Yeah, like,
week after.
like, go on some
Yep. Make sure, guys, listen carefully. If you're going to test this out on your own and you have cruise control in your car, make sure you know how to turn it off.
If you break it, if you break.
Good, thank you. There's a command on there that's off also. It's canceled depending on your car. But if you ever turn cruise control on and suddenly there's a car in front of you that's not going fast and you're going to hit them for cruise control, just hit the brake. It turns cruise control. Okay? Just be careful. I don't want you to hear it. Let's look at an example of that now.
Hey, cruise control. Why is your car telling me have cruise control? I'm just gonna hope you go.
Put it in the park. First you break the help.
Put it in reverse. It happens.
So, my sister, I think this.
Guys, I put some stuff on the sideboard for you to look at tonight and tomorrow. They're not difficult. They're very easy problems. Please write them down. Compared to what we did today, they'll be very easy.
I'm doing it.
I just like the feeling. She was like, usually when they
How to make friends? Oh, I saw this.
You weren't even big. You got in her dad.
Oh, I met your mother next.
You had the time.
Oh, I've seen this episode. I've seen this episode.
That's right.
I'm gonna go to the other show.
and there is no algebra.
Are the speakers on?
All right, I'm going to pause the recording for those who are at home, just because it's going to